In this video, I would like to look at one application problem that involves a quadratic function. We can apply everything that we've learned about the properties of these functions to solve real-world examples. So imagine you have a person standing on a balcony 10 feet off the ground. They throw a ball upward. The ball is going to go up into the air and eventually come down and hit the ground. So I've shown a picture here that represents what is going on in this scenario, and I've tried to model the path of the ball. We're given a function, a quadratic function, that describes this sketched line that I've shown. It models the ball's height in feet above the ground, x seconds after it was thrown. So every point on this graph has an x value, which is a time, and it has a y value, which is a height. So first we are asked, what is the maximum height of the ball? Well, in order to answer that, we need to know what is the vertex of this quadratic function. The maximum height will be achieved at the vertex. So let's take some time to solve for the vertex. One way to do that is to rewrite the function in vertex form. Since we're stressing that in this course, I'm going to take the time to rewrite our function in vertex form. I'm grouping together the terms negative 5x squared plus 20x, writing the plus 10 at the end. Then I'm going to factor out negative 5 from both of those terms. I have x squared minus 4x in parentheses plus 10 at the end. And I'm going to add a number to make a perfect square here. The number that I add is going to be negative 4 divided by 2 squared. So in this case, that's going to equal negative 2 squared, which is positive 4. So I'm adding 4. And then out here, I need to undo that action. So if you look at the entire function, remembering to multiply by this value of negative 5 on the outside, I have actually subtracted 20 from the entire function. Negative 5 times 4 is negative 20. So I need to add 20 out here to undo that action. So what is our function? Our function is equal to negative 5 times x squared minus 4x plus 4. We can write that as x minus 2 squared plus 30. And that tells us our vertex. The vertex of this function is at 230. So what is the maximum height of the ball? 30 feet off the ground. If they had asked how long does it take to reach that maximum height, the answer would be 2 seconds. That's the x value of our vertex. Our second question here is how many seconds does it take the ball to hit the ground? So here we are trying to solve for this point where the ball comes down and hits the ground, and we know that the y value is 0 there, or the h value is 0. So we're solving for x. Well, we can do that by plugging in h of x equals 0, and we can say negative 5x squared plus 20x plus 10 equals 0. I could make this a bit simpler by factoring out a negative 5 and then dividing by that amount. So I have x squared minus 4x minus 2 equals 0. I divide both sides by negative 5, and I get this equation. X squared minus 4x minus 2 equals 0. So I want to solve this in some way to find this x value. I cannot solve by factoring, so I'm going to use the quadratic formula for my solution. X equals the negative of the middle value, so positive 4, plus or minus the square root of negative 4 squared minus 4 times 1 times negative 2 over 2 times 1. Let's simplify this as much as possible. So this is equal to 4 plus or minus the square root of 16 plus 8 over 2, which equals 4 plus or minus the square root of 24 over 2, We could also simplify this. This is equivalent to 4 plus or minus 2 radical 6 over 2. And one final simplification, this is 2 plus or minus radical 6. Now that's the solution to the quadratic equation. If we think about the context of our problem, we are asked how many seconds does it take the ball to hit the ground. We only want a positive value there. It would not make sense to talk about a negative answer. And so we're going to take this positive answer, 2 plus the square root of 6. That's our exact value. If you plug that into a calculator and round it, that's approximately 4.45 seconds. That's how long it takes our ball to hit the ground. Last question. How many feet above the ground will the ball be 3 seconds after it is thrown? So here we are told a time, which is our input value or our x value. And we are asked to solve for the height. Solve for h. So to answer this question, we simply do an evaluation. We need to find h of 3. We're plugging in a time value, an x value of 3. So we rewrite the function, inputting x equals 3, and we evaluate it. I have negative 5 times 9 plus 60 plus 10. That's negative 45 plus 60 plus 10. And we'll get a final answer of positive 25. So 3 seconds after the ball is thrown, it is 25 feet above the ground. That's a little bit after our vertex, right? So it has reached the maximum height and it's coming back down. So hopefully this example gives you just a quick introduction to some of the ways that we can apply the properties of quadratic functions